viewers, welcome to my maths class. Today I am going to explain that new topic logarithms and their properties and applications. Okay, so now see, this logarithm new concept was introduced by the great Scottish mathematician John Napier. So hence he is become as a father of logarithms. So now what is the logarithm? This logarithm word can taken from Greek word that is logos or logos, that is ratio, that meaning what? Ratio, and arithms, so that is meaning of number. The complete definition of the logarithm is ratio number. So already we know that in earlier classes already we learned that what exponents. So exponents and logarithms both are related topics. So if you understand that exponents, now you will get easy logarithms. So what is that logarithm definition? According to here, the logarithm of a number is the exponent to which the base must be raised to produce that number. That means what? In generally, the definition, in general, let a comma n are any two positive real numbers, and x is, if x is a real number such that a power x is equals to n. This is the most important. So then x is called as what? The logarithm of n to the base a. So it is denoted by log n base a. So first of all, listen. So exponents and logarithms. So these two are the both related topics. So for the small number of exponents, suppose for example if you want to find 2 power 4, it is very easy to find. 2 power 4 value is 16 and 2 power 5 32 and so on. So how can you find that 2 power 2020? How can you find the 2 power 100? So it is very difficult to find that by using the exponents laws. So in such situations, so we can use these logarithm formulas and logarithms. John Wallis is the first person who was introduced the relationship between the logarithms and exponents. And so the short form of the logarithm is what? Log. Short form of the logarithm is log. And in log n base a is equals to, what is a here? Base. So right, next topic is conversion of exponential form to logarithmic form. So exponential form to logarithmic form. How it will be? First of all, so we know that a power x is equals to n is called as exponential form, and this logarithmic form of this exponential form is x is equals to log n base a. This is called as logarithmic form. Right? In words, what we can say? This is base power is equals to number. Base whole power is equals to number, and this can be written in the logarithmic form is power is equals to log number base. Log number base. This is in words. So right now, let us see what is the first example. Convert 3 power 4 is equal to 81 to log form. So 3 power 4, 81 is what? Exponential form. 3 power 4 is equal to 81 is exponential form. We have to convert that into logarithmic form. How it will be? So 3 power 4 is equals to 81. So this can be written as what? According to our formula first. A power x is equals to n. Now the power is equals to, we have to write. What is the power here? 4. 4 is equals to, so log, and what is the n number? What is the n here? 81. And what is the base? So here 3 is the base. That's you have to write. So this is the logarithmic form for this exponential form. Okay. So let us see next conversion of logarithmic form to exponential form. Okay, next we will see that what the conversion of logarithmic form to exponential form. So what is that? See, first logarithmic form x is equals to log n base a is, it can be written as a power x is equals to n into the exponential form. So this is logarithmic form and it is exponential form. So now we will see that one example for our problem. Convert log 81 base 3 is equals to 4 into exponential form. See, very easy. Log 81 base 3 is equals to 4. We can write it as what? See, this is the logarithmic form. Now we have to write this into the form of exponential form. So a is here base. So here what is that? 3 power. So x is there, no, x. This is the x. X is equals to, means what is the x value here? 4. So this is 4. 3 power 4 is equals to, what is the n value? 81. N place value is how much? 81. So 3 power 4 is equals to 81. This is known as what? Exponential form for this. Log 81 base 3 is equals to 4. See, so if you observe this, so conversion of that exponential form to logarithmic form as well as the logarithmic form to exponential form. So both are very easy, and so we can say that by these we can say that the logarithms are reversible exponential forms. The reverse exponential, the reverse exponential form is logarithm. So this is the most important you have to observe. The reverse exponential form is known as exponential, the logarithmic form. Okay, right. Now see, we will see that next types of logarithms. Okay, types of logarithms. So generally we have the two types in the logarithms. They are, first one is common logarithms and the second one is natural logarithms. So these natural logarithms are also called as Napier logarithms. Why? Because the logarithms topic was introduced by the John Napier. That's why it's a name. So we can call it the natural logarithm is also called as Napier logarithms. So what is the first one is common logarithms. See, the logarithms to the base 10. Simply we can call it as what? Common logarithm. The logarithms to the base 10 are called common logarithms. So if no base is mentioned for the given logarithmic value, then we can take always the base as 10. So and the common logarithms are also called as Briggs logarithms. So the mathematician Briggs also introduced, and he mentioned some logarithmic applications. So that's why we can call these common logarithms are also called as Briggs logarithms. Okay, right. Next we will see that next natural logarithms. One is natural logarithms or Napier logarithms. See, the logarithms to the base e are called natural logarithms or Napier logarithms. So what is e here? E is the Euler number, and e is equals to 2.718281. It can be denoted by log x base e or Inx. See, this is the notation of the natural logarithms. So where e is equals to, how can we determine that e value? 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus and so on. So you will get it is in higher classes. Okay, so this is the natural logarithms. See, these natural logarithms are used in theoretical mathematics, or Napier logarithms are used in theoretical mathematical problems, and the common logarithms are useful in numerical mathematics. Okay, now let us see that what. So type of definition of logarithms completed, types of logarithms completed, and the next laws of logarithms. Laws of logarithms. Okay, laws of logarithms. So, laws of logarithms. So we have here 11 laws of logarithms. So what are the formulas? So first one is log mn base a is equals to log m base a plus log n base a. This is called as product of log form. And the second one is log m by n base a is equals to log m base a minus log n base a. So this is quotient form of log. And log m power n is base a is equals to n into log m base a. See here, if you observe, n comes to front. This power comes to front, n into log m base a. This is power or exponential form. And the next log m base a power n is there. Base a power n is there is equals to. So this is here m power 1. Let it will be. You can calculate that m power 1. And this base power n, these two will become as the quotient form 1 by n into log m base a. 1 by n into log m base a. This one and this n both comes to front, and they will become as a quotient form, ratio form 1 by n into log m base a. And here log b power m base a power n is equals to. So these, I said, these two powers comes to front, m by n into log b base a. And the next sixth one is what? Log m base b into log b base a. B will get cancelled. We can write log m base a. We can get as log m into base b into log b base a. So now the log a base b is equals to log a base m by log b base m. So by taking the one of the common base, right? So now a power log x base a is equals to x. A power log x base a. It is in the power only. So now a will get cancelled. Then what is the answer? X is the answer. So keep in your mind. And now the ninth one is, so log a base a. Log a base b is equals to 1 by log b base a. And we can take that here the reciprocal. So 10th one is log a base a. Here the value and the base value if the same, then we will get that answer is 1. Log a base a is equals to 1. And the 11th one is log 1 base a is equals to 0. Log 1 value becomes the 0. Right? So these are the 11 laws of logarithms. Okay, so now that we can see that parts of logarithms. So we have some two parts of the logarithms are there, characteristic and mantissa. Okay, now we will see that what parts of logarithms. So characteristic and mantissa. So these two are the most important parts of logarithms. What are those characteristic and mantissa? See, every logarithmic value has two parts. Every logarithmic value, every logarithmic number, it has two parts. So they are integral part and decimal part. Integral part and decimal part. So here the integral part of logarithm is called, the integral part of the logarithm is called characteristic of logarithmic number, and the decimal part of the logarithmic is called mantissa. Decimal part is called as what? Mantissa. And the integral part is called as characteristic. So these two are. So let us see one of the example. Log 3 base 10 value is 0.4771. So here this log 3 value has two parts. So 0.4771. So 0 is called as, before decimal point, it is called as integral part. This is called as characteristic. And after the decimal point, what is there? 4771. 0.4771 is known as mantissa. So 0.4771, we should not consider this 0 here. So for understanding, I have written this 0.4771. So after the decimal point, so those 4771 only called as mantissa, and those, so 0 before the decimal point, it means integral part, that is called as characteristic of a logarithm. Okay, definition of logarithm completed, types of logarithms completed, and properties or laws of logarithms completed, and the next parts of logarithms are also completed. So, and we will get some most important points for those characteristic and mantissa in further classes, in higher classes. So okay, so I hope you understand. So today I have completed that the part 1 of the introduction about the logarithms. So this is most useful for the those who are studying that 10th CBSE or state board syllabus and about 10th class students. Okay, I hope you understand. So thank you very much.